Dzień dobry, drogie panie I drogi panowie. Okay. Okay. I think no one has understood, so I try to start in English. Yes. Ladies and gentlemen, thank you for invitation, Maciek. It's a pleasure for me to speak about PFA complications at your meeting, but please don't treasure me as a German complication electrophysiologist. Yeah, and don't remember as this. Most of the slides I have prepared are preclinical and clinical studies and case reports from colleagues which are really interested as physicians and electrophysiologists to avoid damage to their patients. So that's my disclosures and some introductions. The global market of cardiac ablation is expanding, but very fast. The mostly used energy ablation procedures is actually a radio frequency ablation, as you know. But this will change the next years, fast changing. I think PFA will be the most growing market up to, I don't know, up to date globally, more than 250,000 PFA procedures were done. And at Tuesday, I've heard from the Abbott side that more than 1,000 procedures were performed with the World Balloon. So it's an exciting time, I think. This hype of, I call it hype, of PFA is supported by really fantastic results in studies in registries, but also from the industrial and financial side you have to concern. However, if you are looking at PFA-specific complications, in my opinion, you should also think about all procedure-related complications, because of your patients is equal if they are complications, get a complication of PFA specific or PFA not specific. That's the reason I show you the next slide. This are old data. These data are from the Manifest 17Ka registry, which shows you encircled the green fantastic safety profile with no esophageal events, with no PV stenosis, with no phrenic, permanent phrenic paralysis, but some specific PFA-specific complications which are already reported, coronal spasm and hemolysis, which related to renal failure. And I have to underline there are also 5 other reported cases of death after pulmonary vein isolation due to tamponade, due to head failure, and some other reasons. And that's also to think about if you perform your procedures with all these new technologies. We have to be in mind. Another, in my opinion, very important issue is the manufacturer side user facility device experience database, which is already published and which shows some technical problems which occurred during the procedures. These data, I know this is a limitation of this database because it's everyone can give this information or do not, so it's very biased, yeah. But it shows something that it's PFA technology is a very, difficult technology which has a lot of how can I tell it? A lot of various things you can change, and then you have other problems with the technology. You can be better with a slightly change. You can safer with a slightly change, but you can also be produce more complications. And there's an enormous enormous working from the industrial side to optimize this situation. Here I've showed you a publication from or a state-of-the-art paper from Natale and Michel Nassaguer. And what they summarize that all these results of randomized trials and meta-analyses to date suggest that PFA is safer and more efficient than thermal energy sources. And special attention should be given to PFA-specific complications. That's the reason I talk about. Coronal spasm and hemolysis are the two main ones. I think the number is a little bit various. I take here actually 2 to 4 types of PFA-specific complications. We can discuss about it, but two, the hemolysis and the coronal spasm, are clearly recognized. The slides coming to the first complication, potential complications, the coronary arterial spasm during pulse field ablation. I have to explain that we have, in general, two categories of spasm mechanism or phenomena we've seen also in radiofrequency ablation procedures. There's a generalized diffuse coronary vasospasm, which is often seen after ablation, after the procedure, and we see sometimes regional vasospasm, which is in proximate relationship between ablation element and the coronary arteries. I have some examples which I will show you. The precise mechanism of a spasm is unknown, I think. It was discussed in some papers as an imbalance of the autonomic nervous system. And also we know that there is a dose-dependent manner could be responsible which can reproducible provoked. Here's one example from publication. I don't know, this is one from our center, some pictures here. I would like to show you from CTI ablations with two different PFA systems, which we have experience with this system. And I can only say it's a very impressive, always very impressive to see it, the early effect during first PFA application, which was mostly terminated typical atrial flutter by example with PFA applications. But on the other side, you have keep in mind that there is a close proximity to the coronary artery, and which could lead to vasospasm, which could lead to potential complication. So here's another example which was published by a colleague in 2024, which is also very impressive, other catheter technology, but mitral valve line performed. And during this mitral valve line, you see here the coronary artery with a spasm, and then they gave the nitroglycerin for resolution. But I see here, as you see here, the timeline from the ECG, that was a energy delivery, and it takes 20 minutes to solve the problem. In the description of the paper, patient was not injured after that, but you can imagine that 20 minutes from vasospasm could result in a damage. Yeah. So it's not only a problem during PFA applications in the atrium, also in ventricle, as you know, that's you can imagine. And there are different types of location and procedure types which led to coronary vasospasm. Here an example during AF energy delivery in the ventricle, and resolution after nitroglycerin. There are some papers who or descriptions that they give nitroglycerin as prophylactic dose intracoronary or peripheral, and which could solve the problem that it will really get a problem. So here I have some videos from such a procedure with an Pharopulse PFA catheter, and you can see here the first application with no vasospasm, and then you see this regional vasospasm of the right coronary vein. Then giving at this time point nitroglycerin, and the problem was not solved. It's progressed, but after some minutes the problem was was resolved after giving of this nitroglycerin. That's one part of vasospasm I can show you. Another thing is that you have to be in attention that if you start with energy application, it's an example with first energy application, there's nothing. And you can create more and more vasospasm if you don't check that the vasospasm begins. That means it depends from the account of numbers you give to the region that it will progress. And that's sometimes perhaps really difficult because you don't see perhaps such a vasospasm not really on the ECG. But not everyone does coronary artery angiography during ablation. So you can't see it, and it could be, and that's the most often case, subclinical. And that, in my understanding, the problem, if it's clinical apparent, the problem is really intensive. Yeah, so that's this example. Then I have another example. I just want to show you that's an example of epicardial ablation with PFA. And for me, interesting, and you should focus here the histological results of PFA after PFA ablation. And that's for me, on the other side, very impressive that the coronary artery in this case is really well homogeneous and not destroyed, which means that it's possible this vasospasm mechanism is without any long-standing damage. So another point I would like to talk about is hemolysis. The slide is from Arthur Wermer, which shows the pathophysiological aspects of hemolysis, which is the second important PFA-specific complication. This complication could lead to renal failure. The degree of hemolysis is related to different technical aspects of the used PFA systems, the catheter size of electrical field, and the PFA waveform. But also musculoskeletal stimulation with every application is an issue in myoglobin release and renal failure. So perhaps all of you know this slide shows the applied voltage and number applications and electrode contact, which determine the level of hemolysis. Also seen is here in these two curves that even with an excellent contact, which is here in the blue line, the level of hemolysis is quite significantly increasing with more applications. That means if you do excessive applications, you could create nearly with every system hemolysis. Popper et al. Did investigate the correlation with PFA deliveries with this pentaspline catheter, which really make hemolysis. in several centers, and based on log curves, at this catheter type, that the most severe hemolysis happened with more than 50 PFA applications during the procedure. That's a lot, or seems to be a lot. But as all of you know, PFA is so safe, and every one of us I just do the posterior wall line, I do perhaps the CTI, perhaps cava superior, and I have time, I'm so fast, I do some more application. And then you reach the 51. So be careful and think about it. Perhaps a little bit fewer applications are better for the patient. So here's another slide I've from Verena Scholl from Berlin. She showed some results from their experience with a pulse select system from Medtronic after application, and they told us during the error congress that she never see any hemolysis. I was a little bit critical with this result because she showed only, in my opinion, PVI cases, not extensive cases, as I shown before. But on the other side, I believe there is something on it that if you have another catheter configuration, a fixed configuration of electrodes, it could influence the type of hemolysis, not only the contact. And this is not another example of different systems which can produce or about the severity of hemolysis with different tools and numbers of energy applications needed to measure and the release of hemoglobin, and so you see also the wall system, which is very low to see, and the highest I've already mentioned. So on the other hand, and that's one more aspect, and that I told you not only two, perhaps 2, 3, or 4, and we discussed it during the error concept, that one other important aspect of hemolysis is a coagulopathy. That means that there is a hemolysis associated thromboinflammation and immune dysregulation. In detail, it's too difficult for me as an electrophysiologist to understand, but you have to be in mind that the hemolysis could bring the patient over oxidative stress and so on to perhaps a thromboembolism complication. Yeah. So, and then I have a last, I think, yes, I have time. I have a last issue I would like to present you. That's incidental heating. What does it mean? The last issue, from my point of view, is a term which means that even PFA, which is a non-thermal energy, can produce heating. The often used term that it's not thermal PFA, it's correct if you use it in a small range, but if you extend this range, it could be thermal. And this depends from different issues, yeah? And but you have to keep in mind, and most important thing is this slide, this figure or graphic here, that the main mechanism for me is independing from the system you use. There's a voltage amplitude and pulse duration depending area, where you have reversible electroporation. Then if you go higher to irreversible electroporation, which you want to have, and if you go higher as this, you have thermal effects with every system. But this is a range I think you should try to avoid. This is one publication based on a computer model. I don't know if all of you know them. It's published this year, which makes me insecure because the authors concluded that current commercial viable PFA systems may include collateral thermal injury with repeated impulses. That means we should be in attention that to avoid this phenomenon. I don't know how to discuss, but we can. You can, Christopher, perhaps you can say something to this. Okay. So what do you have to keep in mind that I learned, that was my primary knowledge about collateral heating in PFA. I learned that tissue do have thresholds for injury, every tissue. And that normally the high dose PFA deliveries only produce on an average temperature rise about 5 degrees at 1 second. That should be safe then, but keep in mind the computer modeling I showed you before. Then I saw one additional thing which is really interesting, the investigation about microbubble formation, gas boiling during also PFA. You know this phenomenon from radiofrequency ablation. And that's also the same thing. If you are giving too much power, too much energy delivering over your electrodes, you can produce these phenomena, and these phenomena could be really dangerous for your patients. So that's all I would like to tell you, and would like to conclude with a picture also from Atul Verma, that it's an incredible amount of PFA parameters which influence the effectiveness and the safety. And all these parameters were really good. I think they were really good investigated from the industrial side, but we learn every day some new aspects. And this will be very, very, I think exciting in the future, what the end product of PFA, perfect PFA procedure, product will be. That means, to answer my initial question, have we still reached the Holy Grail? No, we don't have. I think not. I think it's a good way with this tool, because I'm, as you know, I'm a balloon fan, and so it's a good tool. But for the Holy Grail, I think we need perhaps even we will have in some months or years the Holy Grail. Okay, thank you for your attention.